Our topic for this video is reference angles. So for non-acute angles theta, we often find values of the 6 trigonometric functions by using the related reference angle. So let's let theta be an angle in standard position. The reference angle for theta is the acute angle, and we're going to denote that by theta prime, formed by the terminal side of our angle and the x-axis. So it is always formed by the terminal side of our angle and the x-axis. So for quadrant number 1, if our angle is acute, then the angle is meeting the definition of the reference angle, isn't it? Because it is acute, it is formed between the x-axis and the terminal side of our angle. So theta equals theta prime. For quadrant 2, our angle is not acute, and so the angle is not meeting the definition of a reference angle, but the angle that we will be referring to or looking at is the angle right here. And how we find this theta angle is by noticing that our angle combined with theta prime adds to be 180 degrees. So our reference angle is equal to 180 degrees minus our given angle. For quadrant 3, our angle starting from our initial side and ending at our terminal side is past 180 degrees. And so this portion of our angle is the angle we will be referring to. It is our reference angle, and because it is past 180 degrees, but we want to make sure our reference angle is acute, we will be finding the difference. We will be subtracting, but order does matter. So to find our reference angle, we will take our original angle, which is past 180 degrees, and we will subtract 180 degrees from it to find the difference, and that will give us our reference angle. For quadrant 4, our angle lies in quadrant 4 from the initial side to the terminal side, and it is short of reaching the x-axis. And so notice that the combined total of our angle with our reference angle gives us 360 degrees. Therefore, our reference angle is equal to 360 degrees minus our given angle. So let's work with examples of finding our reference angle. So the first thing I'm going to notice about angle number 1, which is 373 degrees, is this is past 360 degrees. So I'm actually going to get a coterminal angle, and I'm going to get a coterminal angle not by adding 360, but by subtracting 360 degrees. And that very much so helps me understand where 373 degrees is, because it is coterminal to to 13 degrees, and 13 degrees lies in quadrant 1. So the reference angle is 13 degrees. If we were to draw this, there's 373 degrees, and there is my reference angle. Now, where does 173 degrees lie? So if we think about where 173 degrees is, it is past 90, it is almost to 180 degrees, so it is in quadrant 2. And so we find the reference angle by taking 180 degrees and subtracting 173 degrees, And so my reference angle is 7 degrees. Where does 253 degrees lie? 253 degrees is past 180 degrees. It is almost to 270 degrees. But remember, and this is very important, our reference angle is always formed between the x-axis and the terminal side of our angle, never the y-axis. So we'll never use 270 degrees to find our reference angle. We'll never use 90 degrees. We will only be using 180 degrees or 360 degrees because that is defining the x-axis. So 253 degrees is past the x-axis, and to find its difference, we start with 253 degrees and we subtract 180 degrees, which gives us our reference angle of 73 degrees. Now notice for our last example, we have negative 73 degrees. So negative 73 degrees indicates the direction of rotation. So our angle is negative 73 degrees, but our reference angle is positive 73 degrees. And one way we can find that is by taking negative 73 degrees, adding 360 degrees to get its positive coterminal angle. That helps us understand that this angle is lying in quadrant 4. And then to find our reference angle, we can take 360 degrees and subtract our coterminal angle, and this gives us positive 73 degrees, which is our reference angle. You have 3 questions. Find the reference angle for 103 degrees. Find the reference angle for 193 degrees. Find the reference angle for 293 degrees. Our next set of questions deals with finding all angles that meet the given condition. So we're going to find all angles to the nearest tenth of a degree between 0 and 360 degrees. So one full positive rotation. So for our first example, we want to notice that sine of our angle is equal to positive 0.3219. So in order to figure out all of the angles that meet this definition, we want to figure out where our answers lie. And sine is positive. Remember this? Sine is positive in quadrants 1 or 2. The next thing we're going to do is find the reference angle. And this is the angle that will provide our answers for both quadrants 1 and 2. So remember, this is sine of our angle, not sine times our angle, but sine of our angle. So in order to find our reference angle, we're going to take sine inverse of 0.3219. And in our calculator, that gives us a reference angle of 18.8 degrees. And if we think about where 18.8 degrees lies, that is in quadrant 1. So that's our first answer. Now the second answer lies in quadrant 2. So what we're going to do is we're going to take this reference angle and we're going to flip it right over the y-axis and get into quadrant 2. Notice this is our reference angle, but this is the angle we're trying to find that lies in quadrant 2. And so those two together add to be 180 degrees, so we need to find the difference between 180 degrees and our reference angle. So our second answer is 161.2 degrees. Now our next example, notice please it deals with a secondary trigonometric function or a reciprocal trigonometric function. And we do not have cosecant in our calculator, and so we do not have cosecant inverse. But I am still going to notice that this is positive. And if we think about cosecant, cosecant is the reciprocal of sine. So that helps me understand that my answers again will lie in quadrants 1 and 2. We will get to that in a minute. So the first thing we have to do is realize I do not have cosecant, so I need to use sine. So if cosecant of our angle is equal to 1.2916, then sine of our angle is equal to the reciprocal of that, or 1 over 1.2916. And now I'm ready to solve for my reference angle, which is equal to sine inverse of 1 over 1.2916. And so my reference angle is approximately 50.7 degrees. And remember, my value was positive, so that means my two answers are going to lie in quadrants 1 or 2. And 50.7 degrees is an angle in quadrant 1, so that is my first answer. And my second answer found in quadrant 1 is by taking 180 degrees and subtracting my reference angle. So my second answer is 129.3 degrees. So those are both of the angles that will meet that original condition. You have 3 questions. Given cosine of the angle equals 0.8321, find the reference angle and round to the nearest tenth. Given cosine of the angle is equal to 0.8321, state the quadrants the angles lie in. And now, given cosine of our angle equals 0.8321, you're going to find all angles that meet that condition to the nearest tenth of a degree, and we're going to limit ourselves to one full rotation between 0 and 360 degrees. Now we're going to determine ratios without the use of a calculator. And the way in which we do this is by understanding our trigonometric functions, where our angle lies, our reference angle, and then also remembering our ratios. So first, I'd like us to think about where 315 degrees lies. So 315 degrees is in quadrant 4. Next, I'd like us to think about sine of an angle in quadrant 4. So is sine of an angle in quadrant 4 positive or is it negative? So remember, sine is only positive in quadrants 1 or 2. So sine of an angle in quadrant 4 is negative. So my final answer for sine of 315 degrees is going to be negative. Next, we need to identify the reference angle. And so our reference angle, theta prime, is found by understanding the relationship between the angle and the x-axis. And so will I be using 180 degrees or will I be using 360 degrees? Well, what is 315 degrees closer to? So 315 degrees is closer to 360 degrees because 360 degrees is 45 degrees past 315 degrees. And notice this is a special angle, which is why we're not going to have to use a calculator. So next we want to recall, well, what is sine of 45 degrees? And so if we go back to our special triangle, this has a ratio of 1, 1, radical 2. So this is equal to 1 over radical 2, but rationalized, that is radical 2 over 2. But remember, we're in quadrant 4, so this is actually our angle, and this is our reference angle of 45 degrees. This is a positive one, but this is a negative one. This is still a positive radical 2. And so that is why our answer is negative radical 2 over 2. So given cosine of 210 degrees, find the reference angle for 210 degrees. State the quadrant 210 degrees lies in. And find the ratio for cosine of 210 degrees. And is this ratio going to be positive or will it be negative?